This is a quick start guide video tutorial for river basin simulation model revision. After installation of revision software on your computer, in order to start the revision program, you can do it in two ways. The first way is you can use the shortcut keys that are created on your desktop, or you can go to the start menu and select all programs. You can select Delta hydraulics, and then under Delta hydraulics, you can select revision. As you can see, there are two shortcut keys that are created after installation. The first one is for basic river basin simulation model development, and the second one, revision delwag, is for detailed water quality modeling development, in which all kinds of chemical and biological processes are simulated. For this case, we will be working on the first basic river basin simulation model. To start the program, double-click on the revision start icon, and then the revision title screen window will appear. On this screen, there are two components. The first one is top screen menu, and the second one is the icon gallery. From the top screen menu, you can use it to exit, and in the icon gallery, you can see various icons. The first one is for opening and simulating an existing model, which will be useful if you want to work on an existing model. The second icon is open and analyze, which will be used to compare the different simulation cases. The third icon is add a basin, which you can use it to create an entirely new basin case. The remaining keys are, this is to delete the basin case, this is also to copy, and you can use this exit also to exit from the window. To build a new model, we will be following serious steps. So the first step to define a new river basin application is you can add here. Double click on this. An important remark is the name of the basin must be maximum 8 characters. It shouldn't exceed 8 characters. For this case, we will be using the Virgin River Basin, so you can give it a name Virgin. Click yes. Then the initial case management tool screen will appear. This is the initial case management tool, which shows a flowchart of 5 task blocks. Each task block represents a task which has to be carried out to finalize a complete simulation case. The arrows between the tasks show the sequential order in which the task must be carried out. The second step is start a new empty simulation case at the case management tool initial screen. Now select at the case menu at the top of the screen. You can select a new case. The color of the box shows the status of the task. Red means you cannot start into unfinished tasks preceding the step. Yellow means you can start working on it, and if it is green, which means you finished correctly, and if it is purple, the task is still running. When you first open a new case, there will be a default case that is created. Later on, you can define, after you work on the simulation, you can give it your own name. To work on each task, you can double click to activate the task box. Then select scenarios and measures. Strategies combo box will appear on your screen. This is the third step, which you can select scenarios, measures, and strategies. So at this point, you have to click on hydrological scenario combo box and select scenarios 1 to 1. For this case, we will be using this first case. You also have to do the same for other combo box and select the scenario management tool. You always have to select all scenarios and management actions to complete this task, and then click OK. So when you successfully finish, you can see the screen is green. Step 4, defining the simulation period. Double click on the yellow screen, the yellow task box. For this case, we will leave everything as it is using the default simulation period. But this is the task box where you enter simulation period for which the simulation must be carried out. We will click OK, and then the task box will be green again. So you continue to the next task. The next task is step 5, in which you design your river-basin network schematization. To do that, you double-click on this task box. In this screen, the first 3 icons are the most important ones. The first one is to edit network and object data, which is for schematization. For the second screen is to generate overview of the database, and the third one is to view table of the database that you already created. We will go over each of these icons step by step. So the first one is edit network and object. First, click on edit network and object data. This screen is the interactive network editor screen, which is called Nature, which has a top screen menu and buttons, an active legend, the network editing buttons, and the background screen where you can see and also do the schematization. So this is what you see, a default schematization that you'll have to delete to work on your own schematization. In order to do that, you have to activate the editing network tool. If this tool doesn't automatically appear, you can always drag and drop it on the screen. So to do that, I can show you here. You can simply use here to drag and drop the node type. You can use this and drop it like this. And for the connection type, you can also do the same. For the operational menu, you can select it like this and drag and drop it like this. For the connection operation, you can choose it like this. So whenever you find this kind of initially default network schematization, first you have to delete this network. In order to do that, you can select here delete node and click like this, then you can delete it. So for this case, we will choose the first one is variable inflow. Choose the operation and add nodes. Just only click one time. The second one is confluence. Then click also one time. The last one is terminal. Click also one time. If the nodes are too small to see, you can always make it bigger by going to the active legend. You can choose network node and you can add it under symbol. If you also want to adjust the node location, you can select them and you can move them. You can choose here move node. You can move it from one point to another. Now it's time to connect these nodes, just like we did we selected on the type of the nodes and we created the nodes. The same we do for connection. You select the connection type, which is surface water flow. And when you connect them, make sure you follow the directions of the flow from upstream to downstream. Then we select here connect nodes. So we start from the first variable inflow and we drag and drop it into the confluence. and the second variable inflow, and from the confluence to the end terminal flow. To make sure the direction is correct, you can go to view the directions of the water by going to options and click again options. From this, go to link, and under show direction, click on define, then apply. Okay, you can see it here, the directions of the flow. If you cannot see the direction arrow, you can go to the active legend and click on network branch, and you can increase the arrow percentage here. The next step would be renaming the nodes and the links that we created. For that, you can select here rename, and the first main node or the main point is here, and type main. The second inflow variable node is the miner. And this is the confluence. This is the terminal, which is the endpoint. Also, we do the same for the links. Click on the first main link, main 1. This would be main 2. And this would be miner 1. In order to see the name of the links and the name of the nodes, you can go to options, click options, and for the nodes you click here name, and for the links as well you click here name. Apply, and it will appear like this. After you finish the schematization, you have to save the network. So click here, file, save network. After you save the network, you click file and exit. So the reason why we exit from the netter is the property data of the nodes and the links will be updated. This means that the property data is filled with default values for the new nodes and links, and that the data for deleted nodes and links are cleared. Step 6 is entering the network data and link property. So double click the edit network data and database on map again. So click here edit network and object data. There are two ways to start property data editing. The first one is from direct from the map. Left mouse button click and right click. You go here from model data and select river basin simulation model. You will see this spreadsheet look like tool to edit or to add the data of the model. The second way to do it is, and you select here edit and model data. It shows you this way, and you can see here the type of flows and the type of nodes that you have entered, and you can select here also the screen shows you whatever you select. From here you click on edit network, and you can get the spreadsheet here as well. So to enter the data, you click on variable, and what we will be entering is actual inflow time series index. So the actual inflow time series index value 1 for the variable index node main, and the value 2 for the variable inflow node miner. So to be sure that you can see it here, the main is on this side and the miner is on this side, but also you can see the IDs. You go from here options, and for the nodes you select ID, so that you can see which one is which. So the main is 1, so the miner is 2. But this might be different in your case depending on where you start entering the node. So this is for the main is 1 and the miner is 2. Apply and OK. So after you enter the data, close this, and Now you can exit. So the next step is step 7. It gives you a step to generate overview of the database that you entered. Click here. So to see the overview of the database, you can click here, View Tables of the Database, and click on Report Tables of Database. This file gives you the overview of the data, including the model data, the network data, time series data, simulation data. So if something goes wrong while you edit or you add your data, you can check by selecting F7 on your computer. Then type in error, then search. You see here there is no error, but you can also see it from the screen. Here no errors are detected. Then you can exit from the file exit and click OK. To finish this step, you click OK here. After finishing schematization and adding the model data, now it's time to execute the Bayesian simulation, which is step 8. You double click here, River Bayesian simulation, which will turn into purple. That means the execution has started. This is also a step not only for execution, but it is also for post-processing, which prepares files, graphs, and charts for the analysis of the result. If the task block execution or the execution of the simulation hasn't finished, or if something goes wrong, you can always check the log file, not only for the execution, but for each task block. You can use right-click and check the log file. So if we go to this log generate DLF file, it will show you the error message, which is in this case there is no errors detected. So after executions of the river basin simulation, you can go to see the result. Double click analysis of basin simulation result. The result will be delivered in 3 formats: on map, on charts, and in reports. In order to see the map, you click here on map. To view the river flow properly, you can use these tools to zoom in, zoom out, and to move the schematization point like this. You can also zoom in and zoom out. So the thickness of the line of the link shows you the amount of flow in the river. This is the main river, and this one is the minor river. In this exercise, we only see flow in the river, but in the next exercise we will introduce users, and we will see the water balance when users added. To see the result in the graph way, you can select here on the link or on the river and select here graph view, which shows you in a different format, but you can also change this. You can double click here and you can change in different types of graph format. Also, to compare flow of these two rivers on the same graph, you can select here. You can also use the keyboard, either Control or Shift key, and select the other one. Then graph view, it will show you the graphs like this. So if you want to change the graph type again, you can click here, and it shows you here different options. You can select here change. You can change it into bar graph type. Okay. And if we can, you can also do this stuff to compare the flows like this. To see the result of the flow on the reverse, you can also select here options, and options again on link. You can select data value and apply. You can see the amount of flow inside the river. So you can also use the right and left scroll button to see the change over the time step. Also, you see the change in the thickness of the river. After you finish reviewing this, you can also see the other options, which is the chart and the report format of the result. You can exit from here using the file exit menu. And you click on charts. So on the result on the chart, you can see different types of results. But then at this point, we only introduced flow on the links, so we will see the flow in the links. Click view and export. So here you have different options. You select here link flows. You can select all, or you can select only one. You can select all like this, and with the time step, with all time steps, select graph. You can see here the same way that we have seen it in the map format, and you can also here export it in a different format. If you want to export it in image or in different format, use this icon. Or if you want to export the result and paste it in Excel, you click here, copy data to clipboard, and you can paste it on Excel file. So you can also exit the same way before, file and exit. 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 The results on the report format. It's a file that shows you the result, and here also you can see different types of result. What we wanted to see is for now overall river basin water balance. You can see it by selecting here, view. You can go to the file. This is the overall water balance of the river basin. Basically, it has main tables, table 1 and table 2. So these tables, this one is the inflow in the system, and this table shows you the water balance, the outflow. So you can also evaluate the result here. Also, you can see this one is per node. You can see the inflow and outflow per node. Or also you can see here the average annual water balance. You can see it on the report as well. After analyzing or viewing the result on the report, you can exit the same way as before. Exit and exit. Okay. So the last step is to save the simulation case. So far we have been working on the working environment. So when you are working under the case management tool and are executing the various tasks, all files which are generated by the program components during the sessions are stored in the working directory. You save and the case under the top screen menu here, case and save or save as. When you save the case, then files, all of the files, all of the cases that you have been working will be registered permanently and securely stored in the case management tool simulation case database. So to do that, you select your case, save as. This was a base case that we have been working, give it a name base case. So as soon as you save your case, the name of the case will also be updated on the top menu, here base case. This was the base case we have investigated, and until then the next video, thank you, goodbye.